Let's go back and try question 1.
Okay, I think I can do it.
Number 1. Find the voltage between points A and B. Use the Ohm's law. How tired are 6 amperes of charges going through 6 ohms of resistance? 6 times 6 equals 36 volts. The difference in tiredness equals 36 volts. Number 2. Find the voltage between points B and G. Here is the tiredness of the charge before and after passing the cell of 60 volts. Compare the charges at A, B, and G. We can just subtract 36 volts from 60 volts. 60 minus 36 equals 24 volts. Number 3. Find the current at points A, C, D, and G. At A and G, there is just one path. Hence, the current of charges is 6 amperes at either point. We need to see how these 6 amperes of charges divide through the parallel resistors. First, let's think of the current at D. Because the voltage between B and G is 24 volts as determined in part 2, the voltage between D and F is also 24 volts. By the Ohm's law, 24 volts divided by 6 ohms equals 4 amperes. This means 4 amperes out of 6 amperes went through the bottom path, so the rest went through the top path. 6 amperes minus 4 amperes equals 2 amperes. The answer is A to 6 amperes, C to 2 amperes, D to 4 amperes, and G to 6 amperes. As shown in the bottom figure, there is no resistance between points B, C, and D, so the tiredness of the charges are the same. Similarly, the tiredness is the same between points E, F, and G. When you put it like this, we can see the number of the charges clearly. This must be Kirchhoff's first law, current law. Number 4. Find the resistance between points A and G. First, consider the resistance in the yellow dotted line as one resistance R. By using the Ohm's law, resistance equals voltage divided by current. R equals 60 divided by 6 equals 10 ohms. Number 5. Find the resistance between points B to G. Here, consider the resistance between B to G as one resistance R. In number 4, we found that the whole resistance of the series is 10 ohms, so we can subtract the resistance of the extra resistor to find just R. R equals 10 minus 6 equals 4 ohms. Number 6. Find the resistance X. We found in number 5 that the resistance from B to G is 4 ohms. The resistors are in parallel, so 1 over 4 equals 1 over x plus 1 over 6. We solve the equation for x. 1 over x equals 1 over 4 minus 1 over 6. 1 over x equals 1 over 12. X equals 12 ohms.
Yay!
Good job!